last presenter is Marcy Ream from FPT Infrastructure.
Hi everyone, thanks for having me today. Thank you to TSP2 for offering us the opportunity to present today. I'm Marcy Ream, I'm the General Manager at FPT, and as a company, we're on bridge decks a lot. We do it for a lot of reasons. We do waterproofing membranes, we're doing spall repair, we're doing expansion joints. So we've seen a lot of preservation problems, a lot of deterioration, and one of the things that we're really active about doing is working with agency owners, with our contractors who are doing the work for us, and also with industry partners to address some of these failures that we're seeing on bridges and what can we do to stop those failures from happening. So most of the presentations this afternoon have been very technical in nature. I'll warn you now, that is not me. I'm not a chemist, I'm not a scientist, but like I said, we're on a lot of decks, we see a lot of problems, and we want to prevent those problems before they happen. So that's what I'm going to focus on today. So the first thing we want to do is come out and look for an integrated solution for you. We don't want to just come out and throw a deck waterproofing system on. If the joint is leaking, the waterproof deck doesn't mean a whole lot for your substructure. We want really long-lasting materials, so we're constantly looking for not commodity things that we're going to put down year after year or every 2 years, but let's get the material life closer to the service life of the structure. In some cases, we hope to match it. In a lot of cases, we're just reducing the number of times. And so with the FEVE, where you're going out twice to fix that bridge or to recoat that bridge, that's what we want to get to. The other thing that we're looking at are new and innovative ways to use materials that were already in use. They're already approved with the DOT. We have a mastic I'll get into, but we're finding different places to use the material for unique repair opportunities. Finally, in-plant and in-field application of products. We've started working with manufacturers making bridge components, and we're putting waterproofing systems in place in the factory. It reduces labor at the job site, gives some control, and I'll share a case study about that too. So the first thing is, what can we protect? When I started with the company, I was involved with bridge deck protection, but there's a lot more that we can do with our waterproofing materials. We can, and we're working on projects right now where we're waterproofing pier cap. We are doing walls, we're doing buried structures. So there's a lot more than just the bridge deck that we can work on. The first thing that we're going to look at when we go out and take a look at a bridge is, what's the environmental and use conditions of this? I live in Ohio. We have tons of freeze-thaw cycles. We have really harsh winters. That impacts what we're going to do on a bridge deck. It's different in coastal areas. It's different in really hot climates. We do a lot of work in Texas. How we address that is going to be very different. We also want to look at, what does that bridge span? Are we going over a really critical environmental area? If we are, we have to be careful about how we place materials on that deck or on that substructure. Now, after we understand where the bridge is and what it does, we want to look at some of the failure points on that bridge. And these are photos from, most of them are from actual applications and places where we've been. This particular failure point is an expansion joint on a bridge in North Dakota. And you can see there are probably 3 or 4 different materials that have been used to patch this joint over a period of time. If the joint leaks, and someone in an earlier presentation this morning talked about annual inspection of bridges. Well, you can do your annual inspection, but you still have 360 plus days of potential failure that you need to mitigate. So we want to make sure joints are tight. The next thing, drainage. We see this all the time. If we go out to put a waterproofing system down, if they don't have drainage properly coming off that bridge, however the bridge is graded, the drains can get clogged if they're not cleaned, if they're not draining in the right direction, water's not going to go to the right place. And if that water is mixing with chemicals and de-icing salts, it's going to corrode the substructure. This second picture, I'll point out just because our company is based in Mount Airy, North Carolina, and they've got this great greenway bike and walking trail. And I've ridden under this bridge. And every time I ride under that bridge, I look at it and I go, oh my God, is it gonna fall on me today? This is what we want to prevent. And this is, I believe, right at the area of a joint. So it's a nice one to throw in there. Deck cracking. The deck on the left is on a project out in the Midwest. I won't name the state because it's only a 3-year-old bridge deck. And that was some pretty copious cracking. And we went up to do a waterproofing membrane on it. And I said to the DOT rep, you know, this bridge isn't very old to have this kind of cracking in it. And he said, oh, if you think this is bad, you ought to see what's going on underneath. We can't have this. So a waterproofing membrane protects it so that that beautiful pure cap doesn't deteriorate underneath. I'll put this one up here. Hopefully down here in the southeast region, you don't see snowfalls like that, but we get those 4, 6, 10 times a year in Ohio. It seemed like it was constant last winter. So it's very common with overpass bridges where you see those support columns there. We'll get big snows. We'll pre-treat with brine. We'll probably pre-treat with a sand calcium chloride mixture, and then we'll get 7 or 8 inches of snow. Now we've got tandem plows, so 3-lane highway. They're going to clean maybe 2 lanes plus a median for safety and emergency vehicles. And these plows are coming in tandem, and they're throwing snow 20 or 30 foot trajectory, and it's hitting those columns. And month after month after month of that snow clearing, this is what happens to those bridge columns in the underpass. I've seen in Ohio, and I don't know who was doing it, but they actually came up with, if you picture kind of a basketball pole that has the wrap on the bottom, the padding that they put on that, they actually wrap the pillars for the winter. And all I could think of was, okay, you're gonna wrap those, the stuff's gonna get up and under and it's gonna come down, and now you've just created a nice cocoon for all of that contamination from the chlorides. So we think we might have a better solution for that. We're gonna upgrade the materials that we use. Again, I'll go back to what one of the gentlemen said earlier. There's a price performance continuum, and your key bridges, your key areas where you can't afford to shut down for long times, you really need to spend more money mitigating the damage, preventing the damage on that. We've upgraded, as a company, we used to do some spray applied coatings, but we upgrade to a polyurethane methyl methacrylate waterproofing system. We're doing this not only on bridge decks, but we're also doing substructure and side structure and buried structure waterproofing with this. Puma is a very flexible material, but it's very strong. It pulls at about 300% elongation, the membrane itself. It passes 40 cycles C1305 crack bridging at very good values, very low temperature. It is all-weather application. I shouldn't say all-weather, all-temperature application. We need it to be clean and dry, just like all materials, but we can put this down when it's below freezing. It also cures layer to layer in about 30 minutes. So it's a quick application. For substructure, it's ideal because it can be manually applied. Earlier I mentioned about being over water or being over a sensitive environmental area. If you're spray applying something, you're either going to have that spray blowing, or you're going to need to mitigate somehow, tarp in your substructure so that the spray isn't going. We've got an applicator doing this, and it's actually the guy harnessed up on the Newark Bay Bridge there. They're doing it manual. We have a thixotropic variant that can go on your vertical sidewalls, and they're doing the horizontal portions of that right up to the steel plate where they're anchoring in the steel components of the bridge. We like this because on non-trafficked surfaces, it can be a 10 to 20 year solution. On a trafficked surface, when we're doing it on a bridge deck, if there's asphalt over it, again, it's a 20-year solution. You go out, you'll replace the asphalt before you replace the bridge membrane. And if you have to take the membrane off, you're gonna grind it off because it is tenacious. This stuff bonds and it sticks. This upgrading the material used, this is an expansion joint. This is the one that I showed you earlier where there were 3 or 4 different repair materials in it. We manufacture a hot applied mastic, and typically that mastic is used for spall repair. Concrete panel highway, we're fixing corner breaks, we're fixing spalls, we're doing joint repair, and it's a really good flexible material. It takes on the compressive strength of the concrete that's around it, and it makes it really ideal for joints on short span bridges. We're not going to recommend this on a big bridge with a lot of movement, but on a short span, we can go in, we can route out the joint, prime it, pack it with fibercrete, bulk it up to give it some strength, and when this sets, you can return to traffic in an hour. So it's a very rapid repair for that expansion joint. And once it's down, we've had this stuff in the ground for 10, 15 years in places, and joints especially, because it's a very continuous type of movement. Mentioned a little bit about the New Jersey Turnpike. The Newark Bay Bridge, we've been working on this project for probably about a year now, and we aren't even close to done because I think there are over 20 piers on this bridge. It's a 9,500 foot long bridge, and I know on the New Jersey Turnpike Authority projection, it's slated for replacement in about 4 years, but they do have waterproofing going on right now on all of the pier caps. So the applicator is going in, they've controlled the application, they don't have to, and if you've seen this, I think the highest clearance is about 135 feet over the water. It's high. This is not something that you want to go in and try to tarp off to keep your spray contained. So they're manually applying the thixotropic version of the membrane, and you can see, I'll just point out here, they're going clear up over the connection points of the steel. So they're encapsulating anything that's going down into the concrete to close off any kind of corrosion entry point. And they've had really good success with this. The next application, this was in Vaudreuil-Dorion in Quebec. You have to forgive my French pronunciation, it's not very good. But this was a precast application. So this is a small pedestrian and cycling tunnel, connects a neighborhood to a school and park area for sporting events. It's a light rail system, XO, and they wanted to have a more safer passage than going over the track, so they created this kind of dugout bridge. The tunnel structure was precast. We did waterproofing application on all 4 sides, and that was done at the precast facility. They then took the precast structure to the site, placed it, painted the front section, the rail was installed over, and that's the result of it. So, unique application. If we can get the waterproofing on before it gets to the job site, we have a lot more quality control in what we're doing, and it's just another way to think about how to get this work done. The last case, and we're working with several of these manufacturers in town, or around the country, this is fiber reinforced panel bridges. So we take the concrete out altogether, and then we don't really have the mitigation problems that come from some of the concrete bridges. Fiber reinforced panels are very strong, and they're manufactured. We have a vendor in Ohio, Pennsylvania, out on the West Coast, but these bridges are going in all over North America. They're applying a Matacryl WS system, which is our wear system, a primer, a body coat, aggregate, and a top coat. And then those panels, some of them up to 20 feet long, are installed at the job site. We do a lot of transit platforms. We're doing pedestrian bridges, vehicular bridges, skywalk bridges. If you're familiar with, there's one in Missoula, Montana, where they've actually bridged a really large intersection where they didn't feel it was safe for pedestrian traffic to be at street level. They built a sky bridge, and it needed to be lightweight, and these panels are an ideal solution for that. So just another innovative way of thinking how to protect what's going on underneath the bridge. Some key takeaways: assess the structure for areas of stress, corrosion, and design kind of a multifaceted approach. We started out coming in, again, just to do bridge decks, but there's so much more to it. Every time we go out on a job, we see something else that we wish we had some influence to look at, pieces of the structure that just aren't aging well or aren't wearing well. Well, we could have done something from the start. So think about that. The deck's just the starting point. Trying new materials and using the existing materials that you have in different ways, we can kind of stretch the usability of this stuff. And I would really ask you to be creative and proactive. There's over 50 vendors here. I think this is the biggest vendor group I've seen at a conference yet. And we're here for you. We're here for the agencies. We're here for each other. Come and talk to us. Tell us the problems you're having. Make us be better at what we do, because, you know, as manufacturers, we can get a little self-centered sometimes and we think our stuff is the greatest. And it might be in a certain application, but it may not be in your area. It may not be in your geography or your traffic conditions. talk to us about it. Make us adapt our formulas so that they perform better for you. So with that, I will thank you. I was quick. I talk fast, sorry. Any questions I can answer, come by the FPT booth, or I think we have a couple of minutes here if there's anything.
Well, it's something that I have been, actually, I apologize I'm asking you this question because it has been more busy this morning. I have noticed that even on the bridge software, when there is a little problem on the deck, and it comes up with a drop down to a sealer, an overlay, or something like that. And I see your presentation now, and you do mention that you do an assessment of the structure. So, for example, on a bridge deck, when you do that assessment, I would assume that you actually measure the chlorides already there, because where I'm going to is, if you have a deck that is already full of chlorides, and you come over to seal it, you're wasting your money.
Yes,
so
you are.
Can you expand on that?
I will tell you a little bit what we do, and there are some tests that we recommend on a bridge deck before you put this kind of system on it, because you really are encapsulating the deck, and you could be encapsulating a lot of crud into that deck, which simply is going to make our system, or really any system, bubble up if it's an impermeable membrane. We really want to moisture test, and we'd like core samples, and we're relying on the agency to know a little bit. We don't actually do the inspection. We're a materials provider, but we've seen enough, and we've had some failures where we're understanding that sometimes the substrate is just bad. So between us, the contractor, the owner agency, and maybe the engineering firm that's working on that, we're asking, what's the chloride reading? What's the moisture reading? And just going a little bit further into that, we've had deck designs where they don't terminate into a waterproof joint, or there's a waterproofing system that already exists that we don't know about, and maybe the contractor doesn't know until they're on the job site, and now we've got to work up details, and it can delay the job. So we're developing a little more robust questionnaire and testing requirement going forward, because the more we do, the more we see issues, we just want to know what's going on. And with some of the inspection companies here, we need to build some relationships with that.
Marcia, just one quick question about your Cooper product.
Yes.
Do you have to do anything to open the pores of the concrete before you apply that? Or is it, you can just apply it right topically?
No, we want clean concrete at a surface profile of a 4 to 7.
So is that done by water blasting generally? Or
Water or shot blasting.
shot blasting?
Yeah. Sometimes if they're taking the deck, if they have to remove an existing waterproof system, they're grinding it off, and we typically get that surface profile. They'll shot blast it and clean it, and as long as it's clean and dry, we're good to go. And then the system's a primer, typically a neat layer of membrane, and then depending on what you're putting on top, it's either a tack coat or a body coat with aggregate.
But weren't you also shown that being put on pier caps and bridge seats?
We do, and when they're on there, they're not really having to scuff up the concrete. It's not a driven system, it's not a trafficked system, so the tenacity of that bond and movement isn't going to be as critical.
You show some cracks on the bridge deck, do they need a separate sealing treatment?
What we do on that, we'll put primer on it, and the cracks weren't through and through cracks, allegedly, we'll see. But when we're doing a bridge deck, we'll treat the deck with primer, and so it'll go in as kind of a seal coat. They actually prescribed in this instance 2 layers of primer, which is really kind of unusual, but we did it. It was their specification. We adhered to it. But we'll go back and mix body coat with filler, with some SNL filler to thicken it up, and we'll treat any of those kind of broader cracks. Typically, if it's over a 1/4 inch, we'll stop and say there's something more that needs to be done here. But for a 1/4 inch crack, we can go in, if there's any small spalls or anything, we'll go in and fill it with body coat before we build up the whole system on it. Thank you all very much. Appreciate your time.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.